All right, this is Mrs. Bolin here with our Unit 7 review. We've got a test coming up, so I'm going to go back and review what we did in Unit 7. Tomorrow will be a review on Unit 8. So first we're going to start with the warm-up. Name one property of a parallelogram. Well, just looking at the word, I know there's going to be something to do with parallel. So both pairs of opposite sides are parallel. That's one of them. Opposite angles are congruent, opposite sides are congruent, diagonals bisect each other. Number two, name one way to show that a quadrilateral is a parallelogram. Okay, well, if perhaps opposite sides are congruent. Okay, name one property specific to a rhombus. All sides are congruent. Okay, so all four sides are the same. It looks like a diamond, right? Or a square. Square is a rhombus also. Square is both a rhombus and a rectangle. Name one property that is shared by a square and a rectangle. We know that diagonals, we know that all angles are congruent. They're all 90 degrees. So maybe I'll just write that. All angles are congruent, which makes them all 90 degrees because they have to add up to make 360. Okay, and there's multiple right answers for questions 1 through 4. It's just to try to get you to think back to what was in your notes from Unit 7. So make sure you guys go back and look at those notes. Don't just copy down what I have, although that would be okay, but there are more right answers than just what I have. Okay, so for number 1, remember that if the angles are opposite each other, they're like directly across from each other and it makes a diagonal, those are equal. Opposite angles are congruent to each other. Okay, so I can write that 4x plus 18 is equal to 62. Okay, so then I would just solve that. If I subtract 18 on both sides, I get 4x is equal to 44. Is that right? Take off 20 and add 2 back on, divide by the 4, so x is equal to 11. Okay, question number 2. Remember that opposite sides are congruent, which means that their measures are equal. So I could write 2x plus 2 is equal to 12. Okay, minus the 2 on both sides, 2x is equal to 10. Divide by the 2, so x is equal to 5. These are a lot quicker than the ones that we just did in the last unit, huh? Okay, going on to number 3. So we know that in a parallelogram, we know that the diagonals bisect each other, meaning that this little piece is equal to that little piece. So I can write 2x plus 1 is equal to 15. And then I'm going to minus the 1 on both sides. So we get 2x is equal to 14, divide by 2. So x is equal to 7. Then question 4, this is the one where it's a little bit harder. So remember, if I go from one angle to the next and it forms a side, that makes them consecutive angles, which are supplementary. Okay, or you can think way, way back when we had parallels cut by a transversal, they were same side interior, which were also supplementary. So supplementary means that they add up to 180. So I'm going to write these out. 59 plus 121 plus 2x has to add up to make 180 degrees. Okay, so remember, when they're across from each other, they're equal to each other. When they're next to each other, they're supplementary. They add up to make 180. So I'm going to combine like terms. Those together would make, oh, that's kind of weird. So if you add those up, you would get 180 plus 2x equals 180. If I subtract the 180 off, then we get 2x is equal to 0. So x is just equal to 0. It's kind of an unusual value to get, but it's still a number. All right, now we're going to start by graphing some of these quadrilaterals and trying to look at it and determine if it's a parallelogram. So we're going to plot the points. So I'm going to plot this one. A is, remember, this is x and this is y. We start by going left or right if it's a minus or a plus, And then the next part, the next thing we do is we go either up or down if it's a plus or a minus, okay? So these are both positive, so I know I'm going right and up. So I'm going right by 2, up by 1. I'm gonna put an A there. B is over by 5, 2, 3, 4, 5, up by 1. C is over by 4, down by 2. And D is over by 1, down by 2. Okay, and so if I want to show that it's a parallelogram, I want to find the slope of all 4 sides, and I want to show that opposite sides are parallel to each other. So I'm going to find from A to B, I'm going to go from C to B, I'm going to go from D to C, and I'm going to go from D to A. Okay, so we want to do all 4 sides. From A to B, that one's easy. It's not going up or down. It's just a slope of 0, right? There's no slope at all. It's not steep up, it's not steep down, it's just 0. Okay, then same thing for D to C. Went over, but I didn't go up or down at all. So a slope of 0, that one's easy. All right, so those ones are parallel to each other. Then C to B went up by 3, over by 1. So up by 3, over by 1. This one went up by 3, over by 1. So opposite sides are parallel because the slopes are the same. So check. We know that that is a parallelogram. Okay, so we're going to do the same thing for 6, 7, and 8. So I'm going to go -2, +3. By the way, you guys should be pausing this, trying it on your own, and then checking your answers. Okay, K is over 3, up 4. L is over 4, up 0. And M is backwards 1, down by 1. Okay. Pretend like those are straight lines. Okay, we're going to go from J to K. We're going to go from K to L. We're going to go from M to L, and we're going to go from J to M. Okay, J to K, I went up by 1 and over by 5. K to L, I went down by 1, 2, 3, 4, over by 1. M to L, I went up by 1, over by 5. And then J to M, I went down by 4, over by 1. So check, opposite sides are parallel, okay? Question number 7, I'm going to graph those ones. E is 1, -3. F is 3, -1. G is 4, -3. And H is 2, -5. 1, 2, 3, 4, 5. Okay. That one's kind of tiny. Okay, so I'm going to go from E to F. I'm going to go from F to G. I'm going to go from H to G. And I'm going to go from E to H. So you just want to make sure that you have all 4 sides there represented. E to F went up 2, over 2. F to G went down 2, over 1. H to G went up 2, over 2. And E to H went down 2, over 1. And if you reduce these, we get 1, -2, 1, -2. So the opposite sides are parallel. All right, last one of those. I'm going to plot those really quickly. So for P, we're at -2, -3. For Q, we're at -2, +2. For R, we're at 4, 2. And S, we're at 4, -3. All right, this one's even easier because we don't even have to count. Okay, so I know that from Q to R and from P to S, those ones are both 0 because they're flat. Okay, from Q to P and from R to S, those ones are both undefined because what kind of slope is that? If I were skiing, I would just be falling. Okay, bloop. So it's not really, you can't really say how much it goes up and over because it doesn't go over at all. It just keeps going up, 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 or down, 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 down forever. Okay, so that one is an undefined slope. So we showed that the opposite sides are parallel to each other. So yes, it is a parallelogram. All right, question number 9, in the rhombus, we know that AB is 37, DE is 12, and then AC, this whole thing right here, I'm just going to draw the whole thing on there, that is equal to 70. Okay, so now the question is, what does AE equal? Well, if the whole diagonal is 70, and I know that diagonals bisect each other, and I just want to find from A to E, then I would just take half of 70. So I know that that's 35. Then if I want B to D, and if I know that little part's 12, then I know this little part has to be 12 also, so the whole thing has to be 24. And then in a rhombus, we know that all sides are the same. So if this is 37, that one's 37, 37, 37. So BC would be 37. All right, question number 10, find the lengths. Now note this one's not asking for X, it's asking for the lengths of the diagonals. Well, because it's a rectangle, I know that the diagonals are equal. So I can write 3x plus 7 has to equal 9x minus 5. Then I'm going to solve for that, minus 3x on both sides. So 7 equals 6x, take away 5. I'm going to add the 5. I know I'm going really fast. Pause the video to catch up. Divide by 6. X is equal to 2. Okay, but that's not the length. That's what X is. But once I know what X is, just like in our last chapter, we can plug it back in to find the variable that we need. So if I plug in 2 to either equation, I'll get the same answer. So 3 times 2 plus 7 is equal to 6 plus 7, which is equal to 13. So the length of both of those diagonals, each one is 13. And if we plugged it in for the 9, 9 times 2 is 18. 18 take away 5 is 13. Same answer. All right, let's go ahead and, that was it. No homework problems for today. All right, that concludes our notes for the Unit 7 review. See you next time.